Google Maps gives you two routes. One takes 45 minutes, the other takes 20 minutes. Both reach the same destination. How does it know which route is the best? AI faces this decision millions of times every second. How does AI always find a better path? This secret is called AI optimization. And in the next few minutes, I will explain this in the simplest possible ways. So, what is AI optimization? You're packing for a week-long trip. You can't carry everything. So you choose only what gives the most value while taking the least space. That's optimization. You're trying to get the best result with the least effort. AI does exactly the same thing. Every AI system has a goal. Maybe it's recognizing faces, predicting house prices, or writing emails. But there are millions, sometimes billions of possible answers. AI has to search through all those possibilities and find the ones that works best. That search process is called optimization. So in simple words, AI optimization is the process of finding the best possible solution while using the least time, data, or computing power. There is just isn't one way to optimize AI. Let's look at the five most important ones: gradient based, evolutionary, swarm, Bayesian, and reinforcement. Gradient based optimization. You turn on the shower. The water is too cold. So you turn the knob a little towards hot. Now it's too hot. So you turn it back slightly, a little colder. After a few adjustments, the temperature is just right. AI learns exactly the same way. AI starts with an imperfect answer, measures the error, makes a tiny adjustment, checks again, and keeps repeating this until the answer is as accurate as possible. That's gradient based optimization. It is widely used in machine learning and deep learning to train models, optimize engineering designs, and solve complex mathematical problems. Evolutionary optimization. You're trying to create the world's best chocolate chip cookie. You ask 100 bakers to make their own version. Every recipe is a little different. Some use more chocolate, some add nuts. Now you taste them. Only the 10 best recipes move to the next round. Then you do something interesting. You combine the best ideas from those winning recipes. Maybe the chocolate from one, the crispy texture from another, and the soft center from a third. Now you have a new set of recipes. Again, you taste them, keep the best, mix their best ideas, and repeat the process. After several rounds, you end up with an amazing cookie recipe. That's exactly how evolutionary optimization works. Evolutionary optimization is used to solve complex nonlinear problems across engineering, artificial intelligence, logistics, and science. Swarm optimization. A colony of ants is finding food. One ant doesn't know where food is. It simply explores. When it finds food, it leaves a scent trail. Other ants follow that trail. Soon, the entire colony discovers the shortest route. That's how swarm optimization works. Many agents explore different options. They share useful information, and together they discover the best solution much faster than working alone. Swarm optimization is useful for routing, logistics, robotics, and scheduling. Bayesian optimization. You're visiting a new city. There are thousands of restaurants. You obviously can't eat at all of them. So what do? Read reviews, try one, learn from the experience, then choose the next restaurant more intelligently. That's exactly how Bayesian optimization works. Instead of trying everything, it makes smart guesses. Each result helps it make an even better decision. Bayesian optimization is used in tuning large AI models or designing drugs where running tests can be slow, costly, or risky. Reinforcement optimization. Think about the first time you learned to ride a bicycle. Nobody could teach you just by explaining. You had to get on the bike, pedal, lose balance, and sometimes fall. The next time, you adjusted your balance, then your speed. With every ride, you got a little better. Eventually, you could ride without even thinking about it. That's exactly how reinforcement optimization works. The AI isn't told a perfect answer. It learns by trying different actions. If an action leads to a good result, it remembers it and is more likely to do it again. If the action leads to a bad result, it avoids making the same choice next time. Over thousands or even millions of attempts, the AI discovers the best strategy on its own. That's why reinforcement optimization is used to train robots, self-driving cars, or even some parts of the large language models. Here are the key takeaways. Think of AI as a student. Data is the textbook. The algorithm is the teacher. The model is the student's knowledge. But optimization? Optimization is the student's daily practice. Without practice, the student never improves. Without optimization, AI never becomes intelligent. Here's this week's small bite book pick. If you had liked to understand how AI actually learns and improves, I highly recommend Deep Learning by Ian Goodfellow, Yoshua Bengio, and Aaron Kurwell. You don't have to read it cover by cover. The early chapters explain optimization, neural networks, and learning in a surprisingly clear way. I have added the book link in the description below. Before we wrap up, let me quickly introduce myself. Hi, I am Unmesh Nadkarni. I am a tech entrepreneur, AI explorer, and builder who loves breaking down complex ideas into simple, practical insights. Through this channel, AI in Small Bites, my goal is simple: to help founders, professionals, and students understand big AI concepts in small, easy bites. In our next video, we'll explore another fascinating AI concept in a simple and practical way. But in the meantime, have a great one.